The sun is the biggest thing in our entire solar system.
But it is far from being the biggest thing in our universe.
So today we're gonna find out what star is the biggest of them all.
Comment down below what you think it is.
What's the largest star in the universe? And why is it that large? And what are stars anyway?
Those are great questions.
Things
I'm
that
pretty
are
sure
about it
like
like
to be
that.
stars. We begin our journey with Earth, not to learn anything, just to get a vague sense of scale. The smallest things that have some star-like properties are large gas giants or sub-brown dwarfs, like Jupiter,
that
the
makes
most
Earth
massive
look like a
planet in the solar
turd.
system. 11.
Oh yeah, I don't know if you guys knew this, but sometimes if we're close to Jupiter in our orbital cycle around the sun, you can actually see Jupiter, and it looks like a really, really, really bright star.
True.
I didn't know that at all.
True. Kind of same thing with Mars.
So they just look like stars, but they don't have any light. So how do they look like stars?
Bro, how do we see the moon, Adam? How do we see the moon?
Bounces light off the sun.
Okay, keep going. How do we see Jupiter, Adam?
It bounces light off Jupiter.
Ding, 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 ding. We got a winner chicken universal dinner.
This guy is so smart, holy smokes. But also, what I was trying to say is I'm pretty sure the sun is not even that big of a star. Yeah, all things considered, it's like a mid to
Yeah, let's
small
find
star.
out, okay?
11 times larger and 317 times more massive than Earth, and more or less made of the same stuff as our sun.
Helium.
Just much, much less of it. The
Stupid
transition
Jupiter.
towards stars begins with brown dwarfs, failed stars that are a huge
Cute little guy.
disappointment to their mums.
Aw,
They have between
relatable.
13 and
So
90
relatable.
times the mass of Jupiter. So even if we took 90 Jupiters and threw them at each other, although fun to watch, it wouldn't be enough to create a star.
Huh.
Interestingly, adding lots of mass to a brown dwarf doesn't make it much bigger, just its insides denser.
Interesting.
This increases the pressure in the core enough to make certain nuclear fusion reactions happen slowly and the object glow a little. So brown dwarfs are a sort of glowy gas giant that don't fit into any category very
Aw.
well. But we want to talk about stars, not failed wannabe stars, so let's move on.
Yes, let's get to the real thing.
That's kind of like the Pluto of our solar system.
Exactly, yeah. Pluto, unfortunately, just didn't have the qualifications to be a planet, so we kind of got rid of it. We just kicked it to the side.
It doesn't exist anymore.
Yeah, it's just like a meteor or something, or like a comet.
I do kind of wonder, like, how big an actual planet can get, because it seems like stars are insanely scalable. Similar to black holes, you can have a small black hole or a ginormous one. But planets, I've never really heard of a planet being like that much bigger than Jupiter, you know?
I guess we would also have to talk about the solid planets or a Jupiter, which is like a gas planet. Because gas planets can get way bigger than a solid planet like Earth or Mars.
Even still though, I've never heard of a planet being as big as our sun, for example. Even in like another solar system or galaxy, I've never even heard of that. So I wonder if eventually, if a planet gets to a certain point, maybe it all collapses within each other because there's too much pressure or something. I don't know.
Okay, it seems like from what science is telling me, Jupiter is pretty big in terms of planets, obviously, but a planet that's made up of gas can only get to about 1.4 times as big as Jupiter before it just collapses in on itself.
I'm a genius. I'm literally a genius.
In sequence stars.
Then it becomes a brown
Once
dwarf,
large
like you were
gas
saying.
balls pass a certain mass
sun?
threshold, their cores become hot.
Yeah, that's like the next stage. If a planet becomes
It
too
turns
big,
into
then
a
it
sun.
turns into a brown dwarf, which is
Sun.
like a very, like tiny version of a sun. So it's like everything kind of just like can evolve into the next thing.
That is crazy. Yeah, because eventually suns get so big or whatever, when they get too old, they cave into themselves, they turn to a black hole.
If they're big enough, they have to be super big for that to actually happen.
From planet to sun to black hole to what? What is after black hole? Oh my God. I think we might have just cracked the code to the entire universe.
Become hot and dense enough to ignite. Hydrogen is fused to helium in their cores, releasing tremendous amounts of energy. Stars that do that are called main sequence stars.
Oh, wow.
The more massive a main sequence star is, the hotter and brighter it burns, and the shorter its life is.
That's probably
Once
our
the
sun.
hydrogen burning phase is over,
Yeah, it's pretty
stars
close.
grow, up to hundreds of thousands of times
What?
their original size.
See, that's what I'm
But
saying.
these giant phases only
Wait, is
last
it-
for a fraction of their lifespan.
Is that gonna happen? Is that gonna happen? Our sun? Are we
Eventually.
Are we in the last stage? Or are we still like kind of in the middle?
I think we have like 4 billion years left of our sun or something.
Oh God!
It's for sure in the billions, Adam. You don't have to worry about it. We're not gonna live that long.
Oh, okay. Well, I take vitamins.
Okay, keep taking them, I guess.
I drink water.
I breathe air.
Be comparing stars at drastically different stages in their lives. This doesn't make them less impressive, but maybe it's good to keep in mind that we'll be comparing babies to adults. Now back to the beginning. The smallest real stars are red dwarfs, about 100 times the mass of Jupiter, barely massive enough to fuse hydrogen.
Look at Earth all the
to
way down
helium.
there.
Because they are not very massive, they are small, not very
They're
hot,
not very
and
massive.
shine
Get outta
pretty
here.
dimly. They are the only stars in the main sequence that don't grow once they die, but sort of fizzle out.
Huh.
Red dwarfs are by far the most abundant type in the universe.
So I'm kind of curious, like, if it fizzles out after, you know, billions of years, could it become a planet? Or does it become like an asteroid? Like, what does it turn into after that? Kind of like what Alec was saying.
My first thought is it turns into like an infinity stone.
But it's still going to be pretty big, Adam. It's not going to be like where you could put it on
so
somebody's
annoying.
hand.
Yeah, it turned into an infinity stone, Adam. Nice.
It could be like all the energy stored into one little ring.
But there's no more energy left, right? It ran out of energy. That's why it's no longer a star.
Okay, I don't know then.
I don't know either. Comment down below if you know.
In the universe. Because they burn their fuel very slowly, it lasts them up to 10 trillion years.
Oh my gosh.
1,000 times
pretty
the
long.
current age of the
Oh
universe.
my god.
For example, one of the closest stars
How
to
do they
Earth
know
is
that?
a
They're just
red
predicting?
dwarf star,
Science.
Barnard star, but it shines too dimly to be seen without a telescope. We made a whole video on red dwarfs if you want to learn more.
Yeah.
The next stage are stars like our Sun. To say the Sun dominates the solar system is not doing it justice, since it makes up 99.86% of all its mass. It burns far hotter and brighter than red dwarfs, which reduces its lifetime to about 10 billion years. The Sun
ahead,
is
son.
7 times more massive than Barnard star.
Go ahead,
but
son.
that makes
Do
it
your
nearly
thing,
300
son.
times
Let's go.
brighter
Pop off,
with
son.
twice its
Yeah.
surface temperature.
Yeah,
Shine bright like a
son.
diamond.
Let's go bigger.
That's my star. That's my star.
Small changes in mass produce enormous changes in a main sequence star's brightness. The brightest star in the night sky, Sirius, is 2 solar masses with a radius
Whoa.
1.7 times that of the
Is
Sun.
that the North Star?
Did anybody realize? But it went from like an orangey red to a blue.
Yeah, it's like when you start a fire outside, the hotter it gets, it actually changes to a blue color because it's burning hotter.
Interesting. Or okay, we could.
It changes colors based on what you're burning. Like if you're burning like newspaper with a bunch of ink on it, it'll change the color of it. But like hot flames, like the sun's as hot as it gets, that's still the color of fire.
No, Sirius A is hotter. It shines brighter.
Let's see.
Yeah, but it probably has different
Gases.
gas in there. That's what I think.
It could. It very well could.
But its surface is nearly 10,000 degrees Celsius, making it shine 25 times brighter.
Oh.
Burning that hot reduces its total lifespan by 4 times.
Oh, wow.
To 2.5
Wow, so it's like
billion
25
years.
times more hotter.
Stars
Yeah,
close
but
to
he
10
didn't say that's why it's that color. Maybe it's that hot because it's a different substance in there. No, Jack Scoogling, stop!
Why are suns different colors?
No! I cannot be proven wrong to Adam.
It's definitely.
Please tell me it's a different gas. Different gas.
Okay, this says that stars can be made up of different gases, which make them different colors.
No!
Nah, I'm just playing. Adam was right.
Yeah, I knew it!
It's all about the
go!
temperature. It's all about the temperature.
Yeah, you feel that, Alec? You feel that heat?
Hot stars are blue or bluish white, whereas medium temperature stars are yellow or just white. And then cooler stars are red, like the red dwarfs.
Duh! Anyone with a brain could figure that one out. Gosh, dude. Burning newspapers? What is he even saying?
But it does say here that dust and gas in space can also affect the color of stars, making them appear redder sometimes.
Redder sometimes.
See? It does do something.
Relax, T-Rex.
Sun have surface temperatures near 25,000 degrees Celsius. Beta Centauri contains 2 of these massive stars,
Beta.
each shining with about 20,000 times the
Where's
power
the
of
alpha?
sun.
Oh my
That's a lot
gosh.
of power coming from
Look at
something
Earth.
only 13 times larger.
Where even
but
are we?
they'll only burn for about 20 million years. Entire
nothing.
generations of these blue stars die in the time it takes the sun to orbit the galaxy once.
Wow.
So is this the formula? The more massive, the larger the star.
So wait a second, guys. So like Alec was saying earlier, with these bigger stars, like these blue giants, eventually when they burn out, they'll turn into black holes. And it seems like because they're so big, they're burning out faster. So in like a couple tens of millions of years, there's gonna be a lot more black holes in the universe.
That's also something we don't have to worry about, Jack.
But I thought you took your vitamins.
Oh, crap.
Some scientists think that black holes are just a theory and not even proven. Just saying.
They
Black
said the
holes
same
aren't even
things about-
proven to be true, really. There's just so much unknown about black holes. I've seen black holes, but not those black holes. All I'm saying is my own personal belief is that we actually, as a human species, still know nothing about anything. And people come to conclusions, but like really, we don't know. I would not be surprised if we fast forward in 1,000 years, almost everything that we think we know today is completely wrong. That's what I mean.
ChatGPT just told me that black holes have been scientifically proven.
Boom! Alex wrong
ChatGPT
again.
lies.
Never invite Alec to a science-based video, dude. Get him out of here.
Wait a second, so you're saying that it's a conspiracy that black holes might not even be real?
He's gonna say the Earth is flat and the moon landing's fake. Here he goes. Let's go.
No! According to current scientific understanding, black holes are not 100% real, in the sense that we cannot directly observe them with light. But there is evidence of observations that there's a gravitational force, all right? But I'm just saying.
Have you ever seen Pluto? Have you ever seen Uranus?
There are pictures of Pluto.
Have you ever seen ChatGPT? You could have just made a random AI image. You could disprove anything.
No.
This is a largest star size comparison. Can we get back to the video?
I do believe in black holes.
I don't
I'm just
care about
saying
black
there is
holes.
a theory out there that they're not even real.
I don't care. I don't care.
Is R136A1. It has 315 solar masses and is nearly 9 million times
Sit down, you
brighter
black
than the
hole.
sun. And yet, despite its tremendous mass and power, it's
We can barely even see the
30
sun
times
now.
the size of the sun.
Oh my gosh.
The star is so extreme and barely held together by gravity that it loses 321,000
Oh, wow.
billion tons of material through its stellar wind.
That is hot.
Every single second.
That is.
Stars of this sort are extremely rare because they break the rules of star formation a tiny bit.
What?
When supermassive stars are born, they burn extremely hot and bright, and this blows away any extra gas that could make them more massive.
Oh.
So the mass limit for such a star is around 150 times the sun.
Oh, that's it.
Stars like
That's pretty small, actually.
R136A1 are probably formed through the merger of several high-mass stars in dense star-forming regions and burn their core hydrogen in only a few million years. So this means they are rare.
So what we're saying is this is like a giant game of Agario for the sun, and they just combine together, and then they burn the fuel of smaller suns that got combined together.
Exactly.
If you think about it, everything is that.
The entire universe is Agario.
That's
Yeah.
the entire life cycle. Even
Yeah.
on planet Earth, that's how it works.
So the suns and the stars, they're technically not living, but they're eating other stars to get more energy.
Right? Just
You're
like
genius.
humans. Maybe they do have brains and we just can't comprehend them.
Short-lived. From here, the trick to going bigger isn't adding more mass. To make the biggest stars, we have to kill them.
Blow them up.
Red giants.
Yes!
Here we go.
When
Now we're
main sequence
talking.
Stars begin
You
to
are
absorb
Alex middle school
hydrogen in their
nickname.
core, it contracts, making it hotter and denser.
Shout out Alex, mom.
This leads to
Alec
hotter
do be
and
hot.
faster
I got
fusion,
big red.
which pushes back against gravity and makes the outer layers swell in a giant phase. And these stars become truly giant indeed. For
Grow.
example, Gacrux.
Gamma.
Only 30% more massive than the sun, it has swollen to about
Look at the sun.
84
Look at our
times
sun.
Its radius.
Wow.
Still, when the sun
feel so
enters the
tiny.
last
There it
stage
is.
of its life, it will swell and become even bigger.
Whoa.
200 times
Wait,
its current
what?
radius. In this final phase of its life, it
Did you guys know that?
It just got bigger than one of the biggest stars that we've ever seen.
It's gonna grow
It ju- it just-
200 times the size that it is right now.
Yeah, it said that other star was only like 30 times its mass or something, but it's like a million times bigger than it.
Did you know that the sun was gonna get that big eventually?
I did not.
That was the biggest glow up in all of history.
I knew
think
that
that's our
right
solar
before it
system in there.
dies. Right before it dies, it gets really big and then small, but I didn't know it got that big.
And then it goes.
So it turns into a red giant and then gets bigger and bigger and bigger, and then it'll blow up, I guess?
Yeah, our sun is a kind of a low-key sleeper. If you guys want to pick an early sun, pick up our sun.
True. So it's gonna eventually, when it gets big, and then it'll shrink back down, because I don't think our sun's big enough to turn into a black hole, but it'll turn into like a dwarf sun, or like something like that, I think.
swallow the inner planets. And if you think that's impressive, let's finally introduce the largest stars in the universe.
Here we go.
Hypergiants.
That's a great name for them.
Hypergiants are the giant phase of the most massive stars in the universe. They have an enormous surface area that can radiate an insane amount of light.
Shout out Scooty.
Let out the
they're
craziest
basically
fart.
blowing themselves apart.
Shout
as
out Gutter
gravity
Hands,
at the
man.
surface is too weak to hold on to the hot mass, which is lifted away in powerful stellar winds. Pistol Star is 25 solar masses, but 300 times the radius of the Sun. A blue hypergiant aptly
Oh my gosh.
starlight.
Mama!
It's hard to say exactly how
insane.
long Pistol Star will live, but probably just a few million years.
Imagine being a planet orbiting that thing. What would that look like in the sky? Like, look how tiny our sun is and what that looks like in the sky. The pistol, it would cover up the entire sky.
It would never be nighttime.
Yeah, what I'm thinking too is that, like, for a planet that is that big, you can't have a planet get too close, right? Because its gravitational pull is going to be too much, so it's going to pull in the close planets.
The only chance would be if the planet is also like similar size ratio, like an Earth is like also 300 times bigger. Because then it would have more of a gravitational pull, like it would be bigger, so it would take more to pull it in. So it would actually even out.
And I wonder if these planets too, like, because they're so big, they probably are able to pull in things from further in their orbit. So they probably have like 50 planets that are orbiting them from really far away.
If giants exist, they would be orbiting Pistol Star.
Even larger than the blue hypergiants are the yellow hypergiants. The most well-studied is Rho Cassiopeia.
I have a feeling red's
star
gonna be the
so
biggest.
bright it can be seen with the naked eye, although it's thousands of light years
I gotta
from
be
Earth.
naked to see that?
At 40 solar masses,
wonder I could see
this
it my
star
first
has
try.
around 500 times the radius of the Sun and 500,000 times brighter. If the Earth were as close to Rho Cassiopeia
Oh my
as it is
gosh.
to the Sun, it'd be inside.
We'd all look like
and
Alec.
we would be very dead. Yellow hypergiants are very rare.
Oh
though.
my God.
Only 15 are known. This means they're likely
How do we know
just
that,
a
though?
short-lived intermediate state.
Telescope.
As the
That's what I'm
star
saying.
grows or
Everything's
shrinks
fake.
between
Nothing's
other
real.
phases of hypergiantness.
I mean, if you actually want to know, it's pretty simple. So they use these ginormous telescopes that use an intricate system of mirrors in order to be able to look super far out into space.
Yeah, but like space is endless, so they can't make a telescope that goes on forever.
No, it definitely doesn't go on forever, but it's in our observable universe, which is really, really, really far so far.
But we have no idea like how far it goes. That could literally be like an ant to us. We have no idea the scale of the actual universe.
Another fun theory. All planets and stuff are moving in the same direction.
Like a reverse Big Bang. It blew everything up and now it's sucking it back in.
I like that theory. That one's fun. That's a fun one.
like it too.
We're all getting sucked all together.
So instead of the Big Bang, it's the Big Suck, the suckening, if you will.
The great suckening of our universe.
Alec will keep tabs on that.
This sucks.
With red hypergiants, we reach the largest stars known to us. Probably the
Scooty,
largest stars even possible.
Scooty,
Did you say
So
Skibbity?
who's the winner of this insane contest? Well,
don't think
the truth
Scooty's number
is,
one.
We don't know.
No, you can't end like
We
that.
don't know
Really
anything.
bright and far away, which means
Whoa.
that even tiny uncertainties in our measurements can give us a huge margin of error for their size.
It's actually very fair.
Worse still, red hypergiants are solar system-sized behemoths that are blowing themselves apart, which makes them harder to measure. As we do more science and our instruments improve, whatever the largest star is will change. The star that is currently thought to be among the largest we've found is Stephenson 218.
Whoa.
It was probably born as a main
Where's
sequence
Scooty
star
at?
a few tens of times the mass of the Sun and has likely lost about half
Oh
its
my
mass by
gosh.
Wow.
now. While typical red hypergiants are 1,500 times the size of the Sun, the largest rough estimate places Stephenson 218 at 2,100.
Oh my gosh.
That's bigger than Scooty.
Shining with almost 500,000 times the power of the Sun.
What?
By
That shouldn't be
comparison,
possible.
the Sun
We could have
seems
so
like
many
a
energy
great
Oh
stars.
my
Our
god.
brains don't really have a way of grasping.
So just to ah!
Let's just assume that they measured it incorrectly. They said that there's a chance. Let's assume they measured it way incorrectly.
Yeah, this is like you versus the guy she tells you not to worry about.
Every time I look at it, I can't believe it.
Jack, you just don't think about it. You literally you can't even think about it. It's ridiculous. It's ridiculous.
Does anybody feel claustrophobic?
I might go back to college.
This kind of scale. Even at light speed, it would take you 8.7 hours to travel around it
At
once.
light speed,
The
we can't
fastest
even
plane
do
on
that.
Earth would take around 500 years.
Oh, that's it.
Dropped on the sun, it would fill Saturn's orbit.
Oh my gosh.
As it evolves, it will probably shed even more mass and shrink down into another hotter hypergiant phase,
That is
accumulate
insane.
heavy elements in its core, before finally exploding in a core collapse supernova, giving its gas back to the galaxy. This gas will then go on to form another generation of stars of all sizes, starting
mini
the cycle
Big Bang.
of birth and death again to light up our universe.
What?
Let's make this journey again, but this time without the talking. The universe is big. There are many large things in it.
He's
Going
still
all the way
talking.
back to
I
Earth.
hate this.
No.
This, I'm not even kidding. I think about this a lot at night, and it makes me not be able to sleep.
Stop.
It really
Stop.
freaks me out.
Stop it. Stop.
actually
I hate
insane.
this. I hate this. I
Stop.
hate this. I hate this.
We
I hate
are
this.
we are smaller
No.
than the atom particle compared to the sun. My mind is blown.
Click the next video.
If you guys want to watch more, click the next video.
Click the next video.
Or not, it doesn't matter. We're all just an ant in the world of the universe. Not even.